I'm Phil, and we'll have a look at the next motor project under motor drives in the CNU's robot course. So let's have a look at it. We've got quite a number of projects we've done already. Now we're going to have a look at the Atom fan project. So we'll just expand it and have a look at my desktop. So everything sits on top of a Lego Techniques base. And on the left middle, I've got a Atom computer sitting on top of a motion base. And on the right below, we've got a dual button going into port B. And on the other port, port C, we've got a unit, which is the fan unit. And perhaps just a little bit of a closer look. This is what our fan unit looks like, and our dual button. And you can see the LCD screen on the Atom computer. So the objective is to control fans, turn them on and off, show the status of the button and the fan. And when it's on, we'll see that on the Atom computer LCD screen. And we're also going to explore how to poll the status of the push buttons. The push buttons will use the blue one to turn the fan on and the red one to turn it off. And hardware-wise, from M5Stack, we're using the Atom computer. And this time I'll use the Atom S3 at the slightly lower cost of $15.50. The motion base costs $8.50, and the dual buttons are $2.95. And we just need some Lego components, and we're ready to go. And also we've got the fan unit over here too at $4.95. So it all fits together like this. So we add to port B our dual push buttons. The fan unit goes on port C, and the Atom computer sits on top of the motion base. And pin-wise, we're going to connect to port C, which is really using GPIO 7 and 8. And on port C, we'll be using 5 and 6. And the overall cost of all that is $31.90 if we use the lower cost Atom computer. Software-wise, well, we've painted our screen. We've got 2 circles, and they track the status of our push buttons when we turn them on and turn them off. And our program is here. We might actually go across and have a look at that on the Chrome browser. And here is the software on the UI Flow 2 IDE. And on the left, we've painted our screen. You can see the different objects as I scroll through them here. And we've got the labels that we'll be writing to. On setup, on the left, we might increase that so you can see it. The first thing we're doing is initializing our pins, 5, 6, 7, and 8. Now, we're not going to use pin 5, even though we have initialized it. We initialize our circles, which we can see on the left and the right. And we also set up our labels to be 1. And in the main loop, we just simply we poll our push buttons. And if they're being pressed, we then fill in the colors. Otherwise, we set them at white. And we do the same thing with the red push button. We just simply check the value. And if the fan state, which is set by the push buttons, if it's on, we then set pin 5, which controls the fan to be a 1. So depending on the fan state, it will be a 1 or a 0. And then we write the label of that fan state on the label 4, which is right over here on the lower right. So the results of all that were that we were able to control our fan. We could turn it on and off, and we could easily poll the status of the push buttons and show that on the Atom LCD screen. Design-wise, we satisfied the criteria of turning on the fan with the blue push button, turning it off with the red one, and you can see the results now on the following video.
Here we have the M5Stack fan, and it's been driven by a Atom S3 computer on top, and on the bottom we've got a motion base, which also supports 2 additional ports, ports B, and the push button to activate the fan is on that, and the fan unit, which is this one, is connected to port C. So let's activate it. When I press the blue button, we should be able to activate the fan. So our fan is now operating, and when I want to stop it, we press the red button. And this is the M5Stack fan.